All right, let's get going. Welcome everyone. Thank you for joining this session. My name is John Bristow. I'm the Vice President of Developer Relations at Octopus Deploy. And today's session is focused on managing Octopus with our Terraform Provider and Go client. So we're going to spend the next, we won't need an hour, but we've got the next hour slotted to go over what this is all about, how it works, why we built it, and why you may want to consider using it when managing your infrastructure via either the Go client or the Terraform provider that's available for Octopus Deploy. Now, to kick things off, you may have noticed that we recently posted a blog post talking a little bit about this. This is from the one and only Rob Pearson. He basically wrote this really high-level article detailing what we've done. And so essentially, in a nutshell, what we've done is we've shipped a new version of our Terraform provider. And I'll talk a little bit about Terraform and such. But basically, what it will allow you to do is manage your Octopus Deploy instances via the command line through Terraform. And there's a whole bunch of heavy lifting that goes on under the covers. But essentially, if you want to get a general sense of what it's all about, you can go ahead and check out this blog post. So bottom line up front, what's new? You know, if you take nothing away from this, other than these points, you've basically gotten the gist. So basically what we have are two key projects, one called Go Octopus Deploy and one called Terraform Provider Octopus Deploy. The first one, Go Octopus Deploy, is our new API client. This is written entirely in Go, and this is available as open source on GitHub. Now, right now we actually have three versions of our API clients. We've got technically four. We've got one that is supported in C#. We've got one that's supported in JavaScript, which is used for our UI. We have one that is obviously provided on PowerShell, and now we have one in Go. And so if you're looking to target the API, which is exposed through Octopus, then you can use this API client in Go if you wish to use it there. The advantages of Go are the fact that it's multi-platform, it's highly concurrent, very scalable, etc. So you can go ahead and check that out if you wish. The other thing that we're announcing is our new version of our Terraform provider. So the Terraform provider for Octopus Deploy allows you to manage your instances of Octopus Deploy via a Terraform CLI or command line interface. If you want to read more about this or get involved in the community Slack, we have a channel there, which is at Terraform Provider. And there you'll be able to submit bugs and provide feedback and ask questions. So hopefully that will serve you well. But essentially what we're providing here in this webinar is a overview of these two technologies. So before we begin, I'd like to take a moment and talk a little bit about the Octopus Deploy API. Now, if you've gone through the documentation, you may have seen an article that looks like this. Octopus Deploy has a rich heritage around its API. In fact, it was built with the API at first. What that means is that all the operations that you conduct through the UI are targeting that underlying API, and it's doing so through our JavaScript client. So basically what that means is that any operation you can conduct in the UI can be targeted via that API. The nice thing about the API is that it's very easy to understand. We would like to think so. It's also hypermedia driven. What that means is that we use these links that are in the API for you to navigate from one endpoint and one address to another. So that allows you to basically traverse the API programmatically, if you will, as you're utilizing it. And that provides some really rich and powerful scenarios. We do also leverage what are called URI templates. We'll talk a little bit more about that later. And the nice thing is that you can use these today. We actually have client libraries, as I said before, in .NET. We can target this via PowerShell if you wish. And now we have our client in Go. Excuse me. So if you want to see this, you can actually walk up to your server or cloud instance and navigate to a UI that's auto-generated by a framework we use called Swagger. So if you go to /Swagger UI, you'll see a rendering of that page. And in fact, we provide a demo link that you can take a look at that. In fact, let's go ahead and take a look at one example of that exact case. So here I've got basically an instance that I'm using, and I'll go ahead and just navigate to Swagger UI. This is the auto-generated UI that we have for navigating all the APIs that are exposed through Octopus Deploy. And so these are all the API endpoints that our UI uses and some of our clients obviously target. And they allow you to perform all kinds of operations against them. If you so wish, you can also take a look at the JSON description itself. It's quite big. There's about 50,000 lines of JSON here, but it's essentially a UI version of that. And the nice thing about the Swagger UI interface is that it allows you to test against these endpoints. So if I wanted to, I could walk up to one of these and say, for example, get a listing of accounts. And by doing so, I can experiment with the API itself. So that's essentially in a nutshell what the API is all about. Now, the nice thing about the API is that, of course, it allows you to it provides this extensibility mechanism for Octopus itself. And so that's kind of the background there of what the API is. And so going forward, one of the things that we've implemented is a API client for Go. And so this is available as a package as Go-Octopus Deploy. You can go ahead and install this very quickly. If you're at all familiar with Go, it's very simple to grab packages and modules and utilize them within your Go applications. It is, as I said before, multi-platform, so you can actually utilize this on Mac, Windows, Linux, etc. And then simply by importing the client, you can then start targeting the APIs that are exposed through the client itself, and it provides a simple mechanism of exposing the model, as well as updating any endpoints that are there. All the common APIs that you expect, the CRUD operations, create, retrieve, update, delete, any types of filters, any searches, etc., are all exposed there. We're just going to go bring up the Q&A here briefly. I think we've got a question. I'm in full screen mode, so this is always challenge. So John asks, one of the features of Octopus we use is dynamic targets for deployment. We find that Terraform setup very useful for setting up the infrastructure. However, we need to use PowerShell commandlet to create the target. It looks like the Terraform Provider can set these targets we'd like to include in our Terraform script. Requires an API key, blah, blah, blah. Is there a method to execute a Terraform script within a Terraform step and automatically provide the script with an authentication or API key and URL? This is a great question, John. I'll go ahead and answer this later, but the short answer is basically yes. You can provide variables in your Terraform scripts and expose or utilize them within your HCL files. So I'll go ahead and point that out where we start getting into the demo. Another question is, what is the GitHub repo URL for this? I'll just go ahead and quickly show you. So you'll find the Go client here. This is at github.com/Octopus Deploy /Go-Octopus Deploy. The Terraform Provider is in our Octopus Labs repo, or rather organization, excuse me. So you'll find those available on GitHub. If you do a search for Terraform Provider Octopus Deploy, it will be one of the first hits. And the same is always also for the Go client. So what can you do with the client? Well, you can create, retrieve, update, delete, all kinds of types that are exposed, obviously, through Octopus Deploy. And so some of you may be familiar with these. Some of you may not have used them. Runbooks may be not a feature you've used, but you can go ahead and create, retrieve, update, delete all of these types within your Octopus Deploy instances. Simply by newing up a new client and then calling the APIs, you can get access to all these types and their associated data. So this is what we've exposed and made available to you. Obviously, this is not a full list of features. There are some things that are obviously missing, but we'll be adding those very shortly as we go forward and continue to iterate on this project as we go ahead. So here's an example of what this might look like in Go. So as I said before, you'll import the package, and there you'll go ahead and provide a number of parameters for initializing the client. So that last line there where you see new client, that's basically creating a new instance of the Go client. Now it takes 4 parameters. The first one is an HTTP request object. This allows you to do some really interesting things in terms of plugging into the client itself. If you want to go ahead and redirect it through a proxy, you can do that. If you leave it as nil, it will just assume the default. The second parameter is your API URL. This is the endpoint where you will access your Octopus Cloud or server instance. The third parameter, API key, is an API key that you will create inside of your instance, and that's very easy to do. You can just simply do it through the UI. However, if you wish, you can also do it programmatically. And then finally, the fourth one is a space that you can specify. So a space ID, you can preset this in advance if you wish to target a specific space. And APIs in Octopus Deploy are delimited or scoped to a particular space. So that will be the space ID. And typically that has a spaces dash number format for referencing spaces. So what are some of the operations and what would they look like? So in the first instance, this is an example of creating an Amazon or AWS account. There are some parameters that are required, and those are all specified in the constructor. And then if I want to create one dynamically and add it to my lists, to my accounts list, I simply just say add, and I get a result back. The second example is an example of getting all the deployment processes that I've defined inside of a project. So I can call the API get all. There are other ones as well. I can say get by ID, get by name, etc. And then the third example is one showing how to get runbooks. So if I want to get a runbook by its ID value, I can simply just call get by ID and give the ID value there. And so all in all, it's a pretty easy to use API. And we've written a number of tests as part of this to expose these APIs and test them out. And so going forward, it should provide a really nice and useful facility for you to target these APIs via Go. So as I said before, Go Octopus Deploy exposes all the sort of CRUD operations that you would have available to you through an API client. These are all supported through, obviously, our API. And as I said before, Hypermedia is supported as part of the navigation for Octopus Deploy. Just to show you an example of that quickly, and again, this isn't planned, but I'll just show you a dynamic example. I'm going to go ahead and walk up to the API here itself. So this is basically our top level listing of the API that's exposed. You might notice that we're using a few things here. These are called URI templates. There's more information you need to know, but basically as you navigate into one of these, for example, so if I take a look at, let's take a look at projects. So go /projects. These are the list of projects that I have here. And down here in this section called links, this is the Hypermedia API that I was talking about earlier. This allows you to essentially navigate from one API endpoint to another API endpoint that's exposed. So I can take a look at all the associated releases with this project, or I can take a look at the channels, or I can take a look at the variables, et cetera, et cetera. So it allows you to, like Hypermedia in a web browser, to navigate from endpoint to endpoint that are related. And again, these are supported through a variety of other operations like the URI templates. These URI templates allow you to specify query strings for specifying search parameters. So if I want to say, get the first 5 channels or get all the channels with this name, I can specify those. But the good news there is you don't have to worry about any of that stuff. You just utilize our client and it will go ahead and do all that heavy lifting for you. So as I said before, Hypermedia is supported, CRUD operations exposed, which is all goodness. So the Go client available, use it, love it if you can. Submit your issues and PRs, it would be greatly appreciated. Available up on GitHub. Which brings us to Terraform, and specifically the Terraform provider for Octopus Deploy. Now, the reason why I mentioned Go at the beginning is because Terraform itself is based on Go. And Terraform utilizes Go for its provider model. And this is why we built the Go client, so that we could actually build a Terraform provider that utilizes it. So it's sort of a necessary step, but actually has the added advantage that if you wish to use Go, you can. But the reason why we built it is for this exact reason. So before we talk about the provider, I think it's useful to talk about Terraform. So Terraform itself is a product available from a company called HashiCorp. And basically what it provides is you to support infrastructure as code and utilize a command line interface for managing your infrastructure. When I say infrastructure as code, you define your infrastructure using configuration. And that configuration is referred to as HCL or HashiCorp. It's like a HashiCorp description. It's similar to what you see with other markups and things of that nature. YAML and JSON, et cetera, come to mind. So HCL is the configuration language that is used to describe your configuration. And then from there, Terraform utilizes that configuration as a form of state. So Terraform will manage that state and apply updates as you make changes to that state. So the fact that it's in a text file that's in an HTML file allows you to make changes, persistent to source control, store it in a secure location, and basically alleviates you the trouble of having to go through UIs. This is the primary reason why a lot of folks want to use Terraform, is because it's really frustrating to have to use a mouse and keyboard to kind of click your way through a bunch of settings just to set up your infrastructure a certain way. So Terraform provides a fast and easy way to do that. And because it's utilizing configuration and can be validated, this allows you to prevent a lot of manual mistakes that can occur. And so you can do a lot of testing and allows you to set these things ad hoc or automatically very quickly. Provides a really good scenario if you're wanting to set these things up quickly through these text files and spin them up, spin them down, etc. So it's a very popular tool. There are many other popular tools as well, but we targeted Terraform because it tends to be the sort of major one that a lot of folks talk about. And as we'll see a little bit later, Terraform is incredibly useful for standing up this infrastructure. So why Terraform for Octopus Deploy? Well, as I mentioned, it can be sometimes frustrating to go through all the point and clicks of a UI. That's not to say that Octopus itself is too cumbersome from a UI perspective, but sometimes you want to stand stuff up quickly. And to that note, we've actually used this for provisioning our own infrastructure for Octopus Cloud. So when we actually update when we update Octopus Cloud, when we create new instances, etc., we update our customers, we're actually eating our own dog food because we're using Terraform for Octopus Deploy for doing just that. So Terraform, the Terraform provider for Octopus Deploy allows you to create resources automatically. So allows you to create all kinds of things, which we'll see, things like accounts, etc. Allows you to define your configuration and then basically provide the series of steps that Terraform talks about a lot, write, plan, or apply configuration for all those types that we expose in Octopus Deploy. As I said, there are numerous resource types supported: accounts, projects, spaces, lifecycles, environments, all sorts of deployment targets, et cetera, et cetera. So you can define these things as HCL and then apply them, destroy them, tear them, spin them up, tear them down, et cetera, and very quickly through the CLI, be able to utilize this for provisioning your infrastructure. So here's the 50,000-foot view of what this looks like. So this is the Go client, the Terraform provider, and Octopus Deploy all working in concert. So essentially what you do is you define and store your configuration as HCL. So there's some text file somewhere that you'll write, and that will be targeted by the Terraform CLI, which is on the left side. Terraform has a number of verbs that they use to describe changes that are made to configuration. So they have this plan phase, which is basically like inspect my state, inspect the configuration, and determine what differences exist. Apply is like commit those changes. Destroy allows you to tear down based on the state that you have stored locally versus the state that you want remotely. And then there's an additional feature which has recently been added to Terraform, the SDK 2.0, which is an import operation, which we also support. And what that allows you to do is walk up to an existing infrastructure, like say if you have an existing Octopus server or Octopus Cloud instance, you can go ahead and import that data that's in there through these import operations. So all of those functions that you'll execute through the CLI will target the Terraform provider for Octopus Deploy, which will in turn utilize the Go client. And the Go client, as you see here, just emits basically all the HTTP verbs against those APIs for updating Octopus server or cloud, depending on whatever you're running. So deletes, gets, posts, updates, etc. And so what this ultimately gives you is a really consistent workflow. You can make changes to your HCL and apply those changes and then know that your state running on your dev machine is going to reflect the state that you want on your Octopus instances. So some of you may have noticed that this provider was available a while back. It was in a 0.5 state. And so what's new? What have we added support for in this latest release? So the biggest one is we've actually targeted the 2.0 version of the SDK. The 2.0 version changes a lot of things underneath the covers. None of that is going to really reflect on the usage model of it, but it does give us better diagnostics, better error handling, better execution, etc. So that's there. We also added a whole bunch of types into the provider itself. most notably around accounts. So specifically, you can target very specific account types like Azure accounts, AWS accounts, username, password accounts, token accounts, etc. As I mentioned before, it utilizes that Go API client for issuing calls, and then in addition to that, we've added a whole bunch of testing and code quality and testing coverage to this. We've had over about 700 code commits since 0.5. We've been working on this for the last few months, and so a lot of changes have occurred in this. Fundamentally, though, if you were targeting this earlier, there's not a lot of changes you would need to make to your HCL. Your HCL should stay largely the same, and that's intentional on our part. Going forward, as we iterate on this, our intention will be to make sure that as we deprecate certain features, we'll make sure to mark those appropriately. And the good news is that Terraform has a model for supporting that. So it will notify you in advance when you go ahead and execute plans, etc., what those plans will entail, how they will invoke changes on your infrastructure, and warn you that you need to migrate certain types. So here's what it might look like if you're utilizing this. So the first step that you need to conduct is you need to initialize an instance of the provider. So this is how you register the provider with Terraform. So you'll make a note here for the source, which is there, and then the version. This is available through the Terraform registry, which I'll show you in a second. And then secondly, you need to define or configure the provider through a set of parameters. So the first one is the address, the second one is the API key, and then you have two optional fields. You can either qualify the provider to work against a certain space by its ID or by its name. These are necessary because of the way we structure our APIs. A lot of operations are scoped to particular spaces, which is why we define them as such. And so when you're defining this, this is essentially how it will look when you configure. Now, before we start looking at other examples, I need to explain one thing about Terraform. Terraform works on two different types. So Terraform defines what are called data sources and what are called managed resources. The literature calls it resources for short. We define it as resources for short. But essentially what they are is a data source basically allows you to read state from the infrastructure and then provide search criteria against those that state and then provide operations against them. Those are reflected in our API. The resources themselves will conduct all the CRUD operations that you wish to conduct against them. So if you wish to create new accounts, delete accounts, etc., those will be done against the resources. In addition to that, with this new import infrastructure, you can go ahead and now import existing infrastructure that's in your Octopus instance against them. So some examples of data sources that are exposed on the Terraform provider include these. As I said before, it's not exhaustive. There are obviously features that are missing. Our intention is to add more as we go along, but these are the ones that you can go ahead and read from. So here's an example. So this is allowing you to basically read in a set of certificates that you have registered in Octopus Deploy. And so what this is doing is it's basically defining a set of filters. You don't have to specify any of these. In fact, you can just say one line here saying, I just wish to get all the certificates. But if I wish to qualify the certificates that I'm getting back, I can go ahead and do so using the parameters that are listed here. Here's an example of users. So this is getting essentially two users that are already defined in my Octopus instance, defined by their IDs. ID users 123 and users 321. I just provide the skip and take parameters there just as an example, but you don't have to define those if you don't wish. So that's an example of how to use those. Now, at this point, what I'm going to do is I'm just going to go ahead and jump into a live demo here and just show you kind of what this looks like. So here I have my command line. I'm running on Mac, but you can run this on Linux and Windows. It's multi-platform, so you can go ahead and target that. So what I'm going to do is just say Terraform. So Terraform is a CLI, and it provides a variety of operations. And so what I'd like to do here is show you how you can pull in data sources. So if I take a look at my state for my Terraform instance here, I don't have any state listed. So I've executed the command Terraform state list, and there's no state listed in my environment. And so what that means is I can walk up to an existing instance of Octopus Cloud or server and start pulling down the state if I wish. So what I'm going to do is I'm going to jump over here, and I've got a TF file here, which is my Terraform file. And what I'd like to do is define a data source for querying the users that are in my system. So first I have to give it a type, which is this one here. These are all defined within the documentation, and then give it a name, which I'll call example. I'll make this simple and just say, give me the 100 first instances of this data source. And then what I'll do is I'll output this as part of the execution. So I'm going to, as part of the output, I'll specify a value, and I'll say its value is Octopus Deploy users, and then the name of the data value there. So what I can do now is I can simply walk up here and apply this change. Now, what this is going to do is utilize the underlying API and provide for me a list of users that are registered in my system. So you can see I have a few registered in my system. It's all mostly garbage data because I've been testing this, but this is essentially what the data source is providing me access to. Now, the reason why this is relevant is if you're writing these scripts and you want to reference certain user IDs and things of that nature, you can go ahead and do so in your HCL. But this is just a listing of the types of users that are inside of my system. And if I take a look at my system here, those will be reflected in the configuration for my environment. So you can see I have a variety of, basically garbage users, but these are the ones that I've been creating. These ones I've been creating with the Go testing, the testing matrix we have for our Go client, and then I'm pulling them down using Octopus Deploy. The Terraform Provider for Octopus Deploy. So this is an example of how we might, if we wish, utilize the data source types that are exposed there. And just to give you a sense of how this is exposed, if you go up to the registry for Terraform itself, you'll find the listing for Octopus Deploy, and it will show you all of the data sources that we expose through the Terraform provider. So you can get access to a wide variety of these types through the data source. So I can take a look at accounts, I can take a look at certificates, I can take a look at channels, I can take a look at machines. So they're all exposed there along with the schema that's associated with them. The setup is also listed here. So if you wish to use this provider, this is basically the HCL that you need to write, and then call Terraform init to initialize the provider itself. So that's what I'm doing essentially in this example. So data sources are useful, incredibly useful for providing these sorts of operations, and allow you to do a variety of other operations like sorting, filtering, etc. The other one, and probably the one that most folks will be familiar with, is what are called managed resources. So managed resources allow you, as I said before, to provide those CRUD operations against the types that you're trying to target. So if you want to create projects, if you want to create users, if you want to create channels, or delete them, or update them, or do whatever it is you wish to do, you can do those through the managed resources that we expose. And so here's an example of what it might look like to create a new account that is a AWS account. So the parameters will vary based on the type. So you may find that certain account types have different required properties as opposed to others. But this is just to give you an example what the HCL looks like. The key difference here is that we're specifying what's called a resource as opposed to a data source. And we're providing a similar set of properties here for reading in those values. Here's what a space might look like. So this is a new thing that we've added to the Terraform provider. You can create spaces. This actually provides a really nice model if you want to create spaces and then tear them down and basically wipe all existence of the space ever being there inside of your Octopus infrastructure. So you can see here we can specify a variety of fields and use those to configure a space that we wish to create. I'm hard coding the user IDs here, but I could certainly do a lookup here if I wanted to for the team members or the team's roles if I wanted to. So I could do quick lookups using the data sources that I mentioned earlier to qualify, the managers for a particular space if I so wish. Getting a little bit more elaborate, this is an example of creating a project. So you can see here I've hard coded some of these values, but this is what you would see inside of your HCL for creating some of these things. But certainly you could do the lookups if you wanted to. And so we support those. Some of these are actually quite extensive, some of these resources that we expose. And so understanding how to navigate those can be a bit daunting. But fortunately, we've got a lot of documentation to help you with that. So you can see we expose a lot of these values and show you how you can use them. And again, those are available through the registry itself. So if I take a look at the example I just showed you, the project example, we provide an example of what this looks like. But then the schema itself is also exposed. So we try to document as much as possible about what's in there as you're wanting to create, delete, update these things as going forward. So there are some other ones in here that are a little bit more elaborate. So we have these things called block lists. And this is a Terraform-ism. Basically, if you wish to create, say, a connectivity policy associated with a project, you need to define a sub block list, and that's an HCL thing. So this is an example of that is in the previous source here. This is an example of, say, a block list that I may wish to create to define certain aspects of my project connectivity policy. These and other things are exposed and documented as part of the schema itself. So with that, what I'd like to do is just take an example schema here, and let's go ahead and build out some types dynamically. So I've got my configuration here, and I've exposed my API key. That's fine. I'm going to blow that away at some point, so don't worry about that. But what I'd like to do is start by taking a look at my infrastructure, and let's go ahead and create some of that as we start utilizing Terraform. So what I have here in my environment, I've got 3 spaces. These are just test spaces for myself. I'm going to create one for this webinar. And so the way I'll do that is I'll define a resource, and I'll utilize the space resource, and I'll give it a name here called webinar space. This is just something that I can reference later on if I want to get its access to its ID. A space by definition has to have a name. So I'll give it a name. And then it also has to have one of 2 fields specified, either team members or teams. Now I'm going to use team members here, and normally you wouldn't do this, but I'm going to go ahead and hard code the ID value for this team member here, which is myself. So the way this works is if I want to provision this infrastructure now, just cancel that out. So the way this works is, I'll bring this up to the top, excuse me. So I'll say Terraform plan. And what this will do is it will go off to my HCL and tell me, okay, Terraform sees that you've got some state persisted in your HCL, and it's proposing the following change. It's going to add these types to your environment. And so if I'm happy with that, let me just move some of these windows you can't probably see out of the way. I'll say Terraform apply. So when I specify this, it will say, this is what you intend to do. Are you okay with this? Yes or no? And I'll say yes. Now, when this is done, it will go ahead and create the space for me underneath the covers using the Go client, and then create it here and give me a result set back. Now, if I want to see what's happening here, I can do it in 2 ways. I can see here, there's my space that I've created called webinar, but I can also see it in other ways. I'm utilizing a tool here called Fiddler. Fiddler is a HTTP proxy that allows me to watch the network traffic that occurs between myself and a endpoint. And I have it configured here to listen for all of those operations that are being conducted against the endpoints themselves. And you can see here, this is the actual HTTP call that was conducted for creating that space. So this is utilizing the Go API client, and it's reflected in the fact that you'll see it as part of the HTTP header. So there's the Go Octopus Deploy from the Go API client. And then it's sent across the wire in a HTTP post. Please, Octopus, please create this space with the name webinar and with this member of its manager team. And it's come back and returned this as a result. So if you wanted to, you could set it up so that you could watch the traffic occur between your Terraform environment and the endpoint, which is the Octopus API. But there's our webinar there. So let's see if we can do some other things. If I'm not happy with that space, I can go ahead and destroy it. So I can say Terraform destroy. And what this will do is say, okay, well, based on the state you have locally, I'm going to go ahead and see, hey, you've got this space listed in state. You wish to destroy it? I can say no. I can also take a look at the state itself. So the way you can do that is you can say Terraform state list. And what this will do is expose what's been created on the client side. So if I wanted to take a look at this instance, I could say Terraform state list, Octopus Deploy _ space, webinar space. So I want to say show, excuse me, not list. So if I say show, there's my state. Now, for those of you who have used Terraform, you'll know the moral of this story, which is state can actually get quite unwieldy, but it does qualify based on the references. So you can actually start building these things up and updating them accordingly. So if I wanted to, I could actually change the name. I could say, I don't want to call this webinar. I want to call this webinar updated, for example. And when I do that, I can say Terraform apply. And it will go ahead and notice that there's a change, a difference between the two, and say, hey, you're going to change the name of this space from webinar to webinar updated. Do you wish to perform this action? I can say yes, and in which case it will actually issue a update and tell you, hey, one has changed. So if I go ahead and take a look at these in the UI, we should see that the webinar is now reflective of that change. So a pretty simple example. Let's take a look at some other resources that we can create. So the next resource I may wish to create is a lifecycle. So I'll say resource, and then I'll create a lifecycle. So this is a sort of common step that we'll take, and we'll call this webinar lifecycle. And again, just because of the fact that this is HCL, does provide a nice capability for me, which is basically I can, hand roll these and create them quickly and easily via text, via the HCL, and I can store these in a location if I wish. Now, the one thing that I want to mention here is that I'm going to have to do something here in order to qualify this lifecycle itself. So let me just go ahead and specify the space ID here. So I'm going to go ahead and create a lifecycle in this space and reference its ID. And before I do that, what I need to do is create a alternative provider here. The reason why I need to do this is because our APIs are provisioned based on a space by space basis. And so if I qualify this as the default space, which is spaces 1, I need to set it to a different space because I want to create the lifecycle there. So the way in which I'll do that inside of Terraform is I'll give this an alias. So an alias allows me to reference this later on. And I can say this is the provider for a new space. And so if I want to, I can then target that by using the provider qualification here. And then what I want to do is specify Octopus Deploy .new space. And so this will be the qualifier for, or the qualifying provider for accessing that. So if we now go ahead and say Terraform plan, so show me Terraform what's going to change. It will show me that I'm going to go ahead and create a new instance of a lifecycle, and it's going to create it using that space ID that I just used, and it's going to use some defaults. So these defaults you can qualify if you wish. You don't have to, but there are defaults that it will pick up and add if you wish. So if I'm happy with these changes, I can say Terraform apply, and then specify yes as the result set. And again, it's using that new provider and making that addition. So it's created a new lifecycle. I can see this in Fiddler if I wish. So going to Fiddler here, you can see there's my post operation, and it's created for me a lifecycle, and it's qualified it here for my application to use. And so I can take a look at that going forward if I wish. I can go ahead and provision new items, et cetera, et cetera. So there's all kinds of things that I can provision. Another example might be, let's say if I want to create a new environment. So let me go ahead and just save myself some typing, and I'll create a new environment. So the way we create an environment is as such, and we can give it a new name. This is how we qualify types within our HCL. And then I'll give it a name of webinar environment. I'll use the new provider type for that. And then I don't need a space ID for this, but I can qualify that as such. So again, I can specify these things. I can say, Terraform plan, again, if I wish, and see the changes that will be reflected based on that updated plan. So here it will notify me of any of the changes that need to be conducted. I can also destroy those changes if I so wish. So the short and sweet story of this is the fact that you can now manage your infrastructure using the provider and see those changes applied through a CLI. You can then take the HCL that you've written and use that to reflect your state and make changes programmatically, basically through this CLI, and see the changes that are listed there, and then have a bit of a workflow associated with managing your Octopus instances. So provides a really, really nice facility for doing that. Excellent. So what's next with the Terraform provider itself? Well, obviously, we want to add some more support for managed resources and data sources. So there are features that people are asking for that aren't there. And we're going to get to them. The setup for this is actually quite good. We've got a really nice framework for building these things out. So releases, runbooks, etc. New data sources for doing them. A getting started guide. I've heard this loud and clear. People want a getting started guide. We're going to go ahead and do that as well. And then if you have any issues at all, please submit them. We're adding tests all the time. We're using TerraTest. We're using a variety of testing frameworks for validating that our assumptions are clear and correct. But if you have any issues at all, please go ahead and submit them. And we love any pull requests that you may submit as well. So feel free to take part of that. Just so you're aware, when we take a look at the repository here, you can see this is the repository for the Terraform provider. The Terraform provider is already getting some issues sent through, so that's great. And one thing that's really nice about this is we're actually building these releases very quickly using Go releaser. So we have a workflow associated with this repo. And when I issue a new release, it will actually generate the builds for a variety of platforms for this, which will again then get synced with HashiCorp, the Terraform registry. So the Terraform registry itself will pick up these changes quickly, and we're going to iterate on this as we go through, including changes to the documentation as we go through it. So my hope is that you'll find this interesting. You'll use it for managing your Octopus infrastructure, and going forward, we'll provide more and more features and capabilities as it seems necessary. So just again, in summary, I provided this at the beginning. I just want to reiterate. We've got 2 projects available up on GitHub. They're both open source and available for you to take a look at. Go Octopus Deploy, which is our API client written in Go. And then Terraform Provider Octopus Deploy. This is the Terraform Provider for Octopus Deploy. It's available up on the Terraform registry, but if you wish, you can take a look at the source code yourself. And then finally, we've got our community Slack channel at Terraform Provider as well, if you wish to take a look. So at this point, what I'm going to do is just pause to see if there are any questions. I've got the 2 posted. Yes. So John posted a question. Is there a method to execute a Terraform script within a Terraform step and automatically provide the script with an authentication or API key or URL? Yes. So what you can do is you can actually specify this inside a variable file. You can read this from secure state. You can I think the recommendation is if you're going to read in an API key value like this, don't do what I'm doing here. Use the mechanisms in place for reading these off environment variables. That's probably one of the most secure ways of doing it. I'm just doing it here just to kind of just show you what it looks like in the raw. But essentially, you can persist this API key in secure storage, or you can persist it into an environment variable and then read off of that. That is a highly privileged operation, so that's why it's a good recommended practice to do that. There is documentation from HashiCorp that talks about how to persist these things, but they're very easy to read into your HCL files. And so if you're wanting to persist things like API keys, etc., that's pretty easy to do. So John's asking a follow-up question. To be more specific, the dynamic target commandlets for the PowerShell script understand the context they are running in and require no additional authentication. Is there a method to provide this same ambient information in a Terraform step, or is the only option to generate an API key ahead of time? I am experimenting with generating the API key dynamically. It is a bit of a chicken and egg scenario, though. In order to talk to the API, you need the API key first. And so it might be such that I can have a login mechanism exposed through the provider. So we've just targeted this way because it's simple and it's easy on me. But I may look at alternatives for, say, if you want to provide a username and password in secure storage and then expose those to generate an API key dynamically, that might be an option. It is not one that we support today, but it is something that I can definitely look into in the future. John, do me a favor. If you wish, please go ahead and write that question or task or issue inside of our GitHub repo, and I'll take a look at it. So yeah, if you have any questions, feel free to post them to the Q&A. I'm just answering them right now. Richard asks, is there any difference, i.e. missing features between Octopus Cloud and on-prem? Yes, there are. It really depends on what sort of angle you're talking about. But it has to do with storage and licenses, etc. Fundamentally, the API is largely the same. And so the types of operations that you'll conduct against cloud and server are largely the same. So an account between, a project group, a lifecycle, and environment, those are all consistent between those two environments. You won't change the way in which you write your HCL for that, but there are differences at a user level between Octopus Cloud and server, and those are well documented on our website. So thank you for that. I think I've answered that live. Done. I'm just going to mark these as answered. Sorry. I'm just going through the questions here. I know you probably can't see this, but I just want to make sure that these are all answered. So it looks like I've answered all the questions. Great. If you have any other questions, please feel free to post them to the Slack channel, as I mentioned before, which is available here. This is available on our community Slack. If you're not aware of where the community is, you can go to octopus.com/community. And there you'll find a whole set of links to support you. So we have a link to our Slack channel, our support, any videos we post on YouTube, feedback, our GitHub, repos, etc., Octopus Labs, which is where you'll find the Terraform Provider, etc. Another question here. Arun asks, does Octopus provide Kubernetes deployment plugin? Well, we do support Kubernetes. I'm not sure if that answers your question. We do expose a resource here for a deployment target. So this is how you would set up, you would perform CRUD operations against a Kubernetes cluster. So these are the required parameters. I need to provide a schema in here. There's some examples that I haven't listed, and this is probably one of them. So if you take a look at this versus an account, you can see I provide examples for the account type. I'm not providing one for the Kubernetes cluster. That's on me. I'll go ahead and make sure I added an example there. But basically, you give it a cluster URL, a list of one or many environments, a name, and then any roles assigned with it. You can then define specific optional parameters along with that. So you can specify, anything associated with its endpoint, if it's running through a proxy, et cetera, et cetera. So there's lots of things that you can specify there. So that is available there for you to use. And in addition to that, there's also an ability to query the available Kubernetes cluster deployment targets you have. So if you wish to go through a list of that, you can go ahead and do so. So I've answered that live. Patrick asks, is there a way to connect to password management tool? Not through the Terraform provider at this point in time. I don't even know if we offer a very good, when I mean good, I mean like, I don't think it's actually in, I'll have to check on that. I don't know if the API is available for targeting that, to be honest. I'd have to double check on what specifically you're looking for. If you do have a concern or a question about that, meaning you'd like to see that, go to one of those repos I mentioned before and submit an issue or submit a question. I'll make sure to answer it there if I can. But we may not have the API exposed for that. So sorry if that's not a good answer, but it's the one that I know. So cool. Excellent. So the current time is we are 10 minutes from the top of the hour. If there aren't any more questions, I will give you, this is me tap dancing, waiting for questions. I will give you 10 minutes back of your time. But just as a recap, go ahead and check out the Go API client. Go ahead and check out the Terraform provider. And hopefully they will help you stand up your infrastructure of Octopus Deploy instances. And make sure and get involved in the Slack channel. So thanks a lot, guys. Really appreciate it. And hope to see you on the next webinar. So take care and stay safe, everyone.